Hello. I've been wanting to try this for a bit. 6 billion. OK, so I've been watching that work in the keynote all morning. I didn't think it actually worked. OK, just say a big number, people start clapping. That's terrific. OK, excellent. Doesn't even have to have a unit or anything.
Hi, hello, I don't have a big number. He's Jake Archibald from the Chrome Developer Relations team.
And he is Alex Russell from off of the full-fat Chrome team.
Who are you calling fat? We've been working on a new web standard that gives you control over the network stack in the browser. It opens a bunch of new doors and exciting possibilities, and we're excited about them.
Yeah, when you navigate to a URL in the browser, a whole load of stuff happens under the hood, deep within the browser. And we were going to kind of show a big technical diagram of how that happened, but instead, let's throw dignity to the wind, and we will visit the browser lands, where over deep within Interface Valley, a new process has been created.
We must create a window object.
But from where shall I get the markup, sire?
Travel on foot toward the browser lands to the HTTP cache.
Should I take the path through the haunted forest of app cache, sire?
No, you fool. We don't know what evil lurks there. Go straight to the HTTP cache and ask the forgetful wizard for the materials that you seek.
But what if he doesn't have them because, say, he forgot? He is known for that.
Then you must travel across the sea of uncertainty to the internet, where the kittens roam freely.
But that is a treacherous journey, my lord. I've seen many a request never return.
Nevertheless, that is your quest. 800 milliseconds later.
I have returned with markup riches fresh from the heart of the internet.
Finally. We don't have everything we need to construct this window object. I see here that we need 2 cases of CSS, an entire silo of JavaScript, and 7 images.
It's OK, my lord. I know the way.
No. Some of these are from another domain. You must take a different path.
And when that CSS comes back, we'll probably find out there's loads more stuff we need, to fetch things like the fonts and extra images. And every trip you make to the internet is fraught with uncertainty. To go there, you're going through your connection to the router, first off, then to the ISP, intermediate proxies, and then the destination server. You get the response, and then you go back through all of those things. And if any of that is slow, the user experience will be slow. And if any of that fails, the user experience fails. The platform didn't actually give you any control over this. And for us, that raised some red flags.
Yeah, it really isn't an extensible place to be. We believe that the web should be extensible, which is to say that if the web decides to give you a car, it should let you take it apart, mix it with all kinds of other things, and build something truly unique if you want to. And we think this is where App Cache went wrong. App Cache used a declarative manifest format that you could control the network with, but only a little bit. It was App Cache's way or the highway, and if you didn't like it App Cache's way, you were sort of out of luck, and it was never quite what you wanted.
Yeah. Also, it wasn't really clear what behaviors you would activate and get when you added a line to this manifest format. It was basically like a grab bag full of caching, routing, versioning, but then topped up with wasps and razor blades. And every time you added a line to this, you were reaching inside there and just pulling something out, usually a wasp full of razor blades.
Yeah. The problems with App Cache are something that I think you've colorfully expounded upon in the past. But let's recap very quickly. Right. So I think we're all up to date on App Cache. And it's kind of a shame that it didn't work out, because many of the features inside of the black box that it presented are really valuable. Caching, routing, versioning.
Yeah, it's no coincidence that some of the native apps that I rely on day to day, they manage the network to create an offline-first experience where connectivity is treated as an enhancement. And each app does this slightly differently in a way that is best for that particular app.
Wait, you use Twitter offline?
Yeah, right. So you get into an elevator. What do?
I talk to someone.
Right, wait, you do what?
I talk to another human being.
OK, so I am English, right? Social engagement in an enclosed space with nowhere to run. No. No, I hold up my phone to my face. It's protection from your kind, you elevator socializers. But it's great because Twitter still opens even though there's hardly any signal in an elevator, right? And it does it really quickly. It does offline first really, really well.
Right. Well, a new web standard brings all of that to your phone in the web. And that new standard is the service worker.
Yay!
Yay?
Oh, that's easy. Brilliant.
We should have used the big number. This is something we've been working on with Mozilla, Samsung, and a load of other third parties. And we've been collaborating with them for a long time now, and we're really excited about it. But enough chat. Let's see what it actually does.
OK.
So here's the quiz app from the keynote that you might have seen this morning. And it's all built on the web, and it has a URL just like any other website. So I like this app a lot. I've been using it for a while. I'm not very good at it, but I'm just going to go ahead and add it to my home screen so that when I relaunch it, I have a nice shortcut. It's quiz app, yeah, great. Oh, hey, it's even got its own icon there. That's pretty great. So I'm going to open that back up, and let's see. Cool. If I go to the leaderboard, I can see that Jake is also playing against me. We're both yellow cats, though. Anyhow.
Yeah, a nice app, buddy. But you see, I'm not really interested in you getting the same amount of points as me or overtaking me. So what would happen if someone were to can I close all of those?
I guess.
Yeah? And I'm going to break your connectivity. What are you going to do now?
Well, I guess I'm just going to keep playing.
Oh, no! So maybe what we should do at this point. So we've been running this live demo, and we've done it this morning a few times. And that seems to happen. That seems to happen like once out of every 5 times.
So it is actually working.
It is actually working offline.
Yes.
Yeah. Pretend you didn't see that first bit. That's great. That means the next demo that we do later on in the talk will definitely work because this one failed. Right?
Absolutely.
That's absolutely
yeah,
brilliant. OK. So can you still use the app in that state?
Yeah. I mean, I just loaded this offline, and I'm going to keep going. Gorgonzola is a soft cheese with blue veins in it. Yeah. Hey, cool. Great.
And that worked all offline, absolutely first time.
Yeah.
Brilliant. That's excellent.
Time,
good to hear. Excellent.
First, second time.
So even though the app is an online social experience, it was being protected from bumps in the road using the service worker. Regardless of the connection state, everything works, and it works really fast. So let's go back to the slides here. And you want to put your phone back on online mode. So the Serviceworker Spec is still in development, as you can see from the slightly, first demo didn't quite work. But Chrome and Firefox are hot on the trail of development here. This little microsite will tell you the status of various parts of Service Worker. If you're wanting to play with it today, you'll need a copy of Chrome Canary, which is our nightly build. You'll also need to enable some flags, the details of which are all on that site. Anyway, how do we make this quiz app work offline first? Well, we started by registering for one of these new service worker things using just JavaScript on our page. The behavior of service worker is defined in this resource, which is just JavaScript.
Right. And by registering a service worker, you kind of set up a base of operations in the kingdom of service workers. It's not in Interface Valley, and it doesn't have a DOM. So it runs on its own thread. And once we get it set up, it can manage requests for pages and handle resource fetches, that sort of thing.
Yes, but first we need to get it ready for action. So one of the huge advantages of the web is that it doesn't have an install process. You don't need to install a website in order to use it. However, installation is the point that native apps use to get all the resources so they can use them offline. So we're going to have our cake and eat it, right? The user is already on the site. They're using it uninterrupted. But the service worker, which is all happening in the background, does have an install process.
Right. And you get to participate in that install process using the install event. It gets thrown to the service worker script which is downloaded and evaluated the first time the browser sees that registration for the service worker. It's your opportunity to get everything ready before the service worker begins to handle navigations and control pages.
Yeah, and you get to pass a promise until this function. This is event.waitUntil. And that promise will define the length and success of the installation process. Because a single service worker could be handling many connections at once, pretty much everything is async. To make this easier, promises arrived in JavaScript in ES6. Largely thanks to this guy here. He did a lot of the work. And they're already in Chrome, Firefox, Opera, and they're making their way into Safari and IE.
Right. So in synchronous code, you call a function, you get a return value, and then you do something with it. And if there are errors, you can handle them with the try and catch block. But what if this do something method was asynchronous? Well, if it returned a promise, you could do the same stuff. The value comes back to you in the first callback, and you can handle errors in another callback if you like.
So you can do loads more with promises than just this, but to go for it would require a session of its own, and we're not going to do that. For the sake of what we're going to cover today, all you need to know is that if something returns a promise, you can put .then at the end and pass in a success callback and a failure callback. You can also chain these .thens together to do async things in a sequence. And you don't need to provide both callbacks for each one. In fact, if you do .catch and provide a callback, that's exactly the same as .then with just a failure callback. If you want to go into detail with promises, and I recommend you do, check out this article on HTML5 rocks. Every hit that article gets helps me justify my employment here, so do please give it a few refreshes just for me.
He could use them. So what do we want to do during this installation process? Well, I guess we need to do everything that we hope is going to be done by the time our application gets started again, right? So because service workers install asynchronously, it's not preventing the user from interacting with your site. So you can deploy all the troops. This is the perfect time to deal with the internet and uncertainty, and you can fetch everything that you need right there. And then when you get all the resources that you needed, send them back to your data storage area, the data keep. The service worker has access to the usual data stores like IndexedDB and the file system API, but unfortunately not local storage.
You say unfortunately, but yeah, local storage is synchronous. And reading from disk synchronously is just a terrible idea. It was a real mistake in the web platform that we have that API like that. Think about when you're driving, right? And you get an itch on your arm. And it's fine, right? Because you can drive and you'll scratch your arm and everything's OK. That's because human beings are sort of asynchronous by default. We can do many things at once. One thing that humans do, which is largely synchronous, is a sneeze. So once again, if you're driving and you need to sneeze, there's a moment, a small moment, where all you can deal with is the sneeze and nothing else. And you just have to kind of hope that no one dies, really. We must avoid code that is sneezy for that reason.
Yeah, so less sneezing and no local storage. It's banished from the service worker kingdom for everyone's safety.
Yeah.
So don't worry, though. We have added a new type of data storage to the platform to help you deal with these sorts of resources. The Cache API lets you store responses keyed by requests. It's like the HTTP cache, except it's unique to your origin, and it's completely programmable. Things are only added, removed, or updated from these caches when you add, remove, or update them. So in this instance, we're going to create a named cache called static v1, and then we're going to add the files that we want to it. They can be from other origins, so don't worry if you've put resources out on the CDN. For the quiz app, we wanted every resource that it needs to display to be in this cache. All the HTML, the CSS, the JavaScript, and the images.
Yeah, and my slides change. Come on. Right, so the methods for doing all of this, the create method and the add method, they return promises. So they're ideal for passing to this event.waitUntil method. So if any of these items in the cache, if they fail to cache, the promise will reject, and therefore our installation rejects as well. And if that happens, don't worry about it. You will get another shot at it later on. But that means if the install succeeds, then we know we have these items. There are dependencies. There are installation dependencies. So once installation completes, the service worker will start controlling new pages. So back in the browser lands, deep within Interface Valley, a new tab opens.
We must create a new window object.
But from where shall I get the markup, sire?
I don't know. Journey to our forces in the service worker kingdom They'll know how to deal with this conundrum.
And that surfaces as a fetch event. You'll get one of these for every page request within the service worker scope, but you'll also get it for every request created by those pages. So the CSS, the JavaScript, the images, XHR fonts, all goes through the service worker, even if those requests are to other domains.
Right. And you get as much information about those requests as we can safely give you. But the really fun part is being able to hijack the request and provide your own response. All you need to do is call the respond with method of the event and provide a response object or a promise that will eventually resolve to a response object. You have absolute freedom in how you do that. It's like having a completely programmable proxy right there on the client.
Right, so at your disposal, you have information about the current request, like the headers, the URL, et cetera. You have access to the data stores, so IDB file system and this really helpful cache API. You also have access to fetch, which will take a URL or a request object, and it will give you a promise for a response. And it doesn't have to be the same request that you're currently handling in the service worker. It can be to anywhere on the web. We've also got event.default, which is a nice helper for just doing what the browser would normally do in this instance. But you can also create responses just manually using the response constructor. And you can pass in text like we have here, but you can also pass in a blob or an array buffer.
And I think the best part about this is that you don't have to pick just one. You can fall back from one response type to another, or you can even race multiple requests across the network to the local disk. Basically, you can do whatever it is that you want to do that's best for your application. So for the quiz app, we handled most requests by responding with something that matches from the cache. Not everything has a matching cache entry, though, such as posting answers or analytics pings. So for those, we catch things without a match, and then we go to the network instead.
So that will work for the CSS, the JavaScript, HTML, the images and things. Assets that would only change shape if we were making like a new revision to the app, if we were sort of releasing a new version of it. And there are many exceptions to this. In our case, such as the leaderboard that you saw, we wouldn't want to cache the leaderboard as installation and then just always serve it from the cache like this, because it would never update, and it's a resource that's going to constantly update.
Right, so let's do something slightly different for the leaderboard requests. First, we're going to parse the URL from the service worker and the URL from the request. The URL constructor that you're looking at there is fairly new in the web platform, but it breaks up URLs into their component parts. So no more nasty string munging to try to match a URL. If the request URL is to the same origin as our service worker, and the path is leaderboard.json, we're going to defer handling to some other method. So what should that method do?
So it's really tempting at this point to flip things over and go network first. Try and get the leaderboard from the network, and if that fails, get whatever we have in the cache. But that means showing nothing to the user while we wait for the network to return, or we wait for it to eventually fail. And that's a really weird thing to do when we know we have information sitting on the user's device. So instead, let's load the shell of the page directly from the service worker, straight from the cache. And then we're going to start a spinner, so we're letting the user know that we haven't quite finished yet. And then we're going to look to see if we've got an old version of the leaderboard in the cache. And if we do, we're going to show it, and then we'll go to the network. We'll try and get a fresher version. If we didn't have anything in the cache, that's OK. We'll go just straight to the network. And once the network returns, well, we'll cache that new response, and we'll update the page with it, and we'll stop the spinner, because we're done. Now, if we fail to get something from the cache, and the network failed to return, that's a problem. We're showing nothing. In that case, we need to show some kind of an error. But if the cache got something, but the network failed, we'll just fail silently at that point. This is a pretty good offline experience. This requires the page to make two requests, one that goes to the cache only, and another one that goes to the network only.
Right, so how do we do that? Back on our page, here are the two requests. They're identical, except the cache request contains this magic header. It doesn't do anything by default. We're just tagging the request.
And we can pick up that tag over in our service worker. So we're going to see if the request header has this magic header that we applied, and if it's there, we're going to respond just with a match from the cache. So if there's nothing in the cache, that's going to get a rejected promise, and the request will fail. But that's exactly what we want. If that header isn't there, then we'll go and get our static v1 cache, and we're going to ask it to fetch a fresh version of the leaderboard and store it in the cache. And if that completes successfully, we'll also pipe it back to the browser.
This is the sort of thing that you can't really do with a non-extensible feature like app cache. Service workers aren't just a framework for building things offline first. They're a series of tools that you can do whatever you need to with.
Yeah, so, I don't know, how about polyfilling a new image format? Imagine we could do that. If the request is for an image, we're going to make the default request. And if what we get back has this header, the content type for this new amazing image format, then we'll transcode it to PNG before sending it back to the browser, to something that it definitely already understands.
OK. But let's kick it up a notch. What about client-side templating? You could just import your favorite templating engine, and then look for navigation requests where the URL contains /article/. Then you can fetch that URL with .json added to the end instead, read it back as JSON, get a template from the cache instead, read the template as text, then serve up a custom response as HTML once you've transformed the template with the JSON using the templating engine that we already imported.
Yeah, OK. Or we could respond to every image request with a picture of a kitten, if and only if it's a Thursday.
Huh.
I got the clap.
You could even post messages from your page back to the service worker. That makes it trivial to implement things like a save for offline viewing button. It lets you have the user help you decide what they want to cache. When we got together and we designed all of these APIs.
Not my line. Sorry, I thought it was my line next.
Oh.
Do carry on.
Oh. When we got together.
I like speaking, you see, so it feels really natural to just talk over you. Sorry.
When we got together and we designed these APIs, one of the things we didn't want to do was weld them down. It's a mistake that app cache made. It tried to be the shortcut before really understanding what the destination was. So instead, what we're doing is providing low-level tools that give you the flexibility to do lots of exciting things, hopefully stuff we haven't even imagined yet.
And what's more, if we look at something like the app cache manifest format, if you reach into the app cache grab bag and end up with a waspy hand, which you will because it's terrible, there's not a lot you can do other than go and read the specification and try and find out why all of that stuff happened, or convince yourself that it's actually a browser bug. If the service worker does something you don't expect, if it does something you don't understand, what then? Well, it's JavaScript, right? We know how to debug JavaScript. Even at this early stage, you can go to Chrome Inspect, and you'll see the service workers there right next to the shared workers. But you can dive even deeper. You can go into Serviceworker Internals, which will show you that all the service workers that are running across all the sites. You can see their logs there. But you can even launch straight into DevTools. And from there, you'll see all the console logs. You can set breakpoints, step through code line by line, all the debugging power that you've come to expect from DevTools.
Yeah, and this is just the start. We're also in the process of adding throttling and offline connection modes to DevTools so that you'll be able to see how things work with a flaky or non-existent connection.
Yes. So we've done a lot. We've said a lot of exciting stuff. I think it's now's the moment really to tell them about the thing.
What thing?
You know the thing, the catch.
OK, all right. Turns out that being able to control every single network request to your origin and the request that your origin makes to other origins is super powerful and awesome. It's also super powerful and awesome for a middleman who might subvert your service worker to do something awesomely terrible with it. So yeah, for that reason, you can only register for service workers for origins that are secure, that are served over HTTPS. And that's the way that we know that the service worker hasn't been messed with on its way to your browser.
And this isn't a theoretical concern either. I got back from a trip to Turkey a couple of weeks ago, and days after I'd got back, when I was browsing the web, I was getting pop-ups for Turkish sites. I assumed they were adverts, but I couldn't understand it. Well, what had happened is, because I was over there, I didn't have data, I didn't have a SIM card, so I was using lots of free Wi-Fi in pubs and restaurants. And at some point, and I don't know when, some bad player there, some evil ISP or evil router, it injected pop-up scripts into a popular CDN copy of jQuery. And the only way I could get around that is to flush the cache. And that's pretty bad, right? But it's something I could actually I could rescue myself from by flushing the cache. You do not want that happening with a service worker. People would get instant control over many origins at once. So the HTTPS restriction is an absolute must.
Right. So the good news is that localhost is exempt from this policy, and lots of project hosting sites like GitHub and App Engine are providing SSL hosting for free already. There's also some certificate authorities like StartSSL that are starting to hand out free SSL certificates for your own servers. But I think the backdrop here, if we step back just a moment, is that in 2014, it's really just the responsible thing to do to be serving our users' data to them encrypted. So it's time to do that.
Yeah, indeed. So the service worker is really powerful, as we said, but everything we've shown so far has required the interface to contact the service worker, and then the service worker can spring into action. But if I look at the native apps that I rely upon day to day, these can synchronize in the background. They can give me notifications. Well, we're going to bring that to the web as well, thanks to these specifications: background sync, push API, and the notification specification.
Cleverly named.
These are, once again, done by a lot of people that aren't us, right? It feels like we're just taking a lot of credit for other people's work. It's basically my career. So these allow the service worker to start up on an interval or in response to a message that comes from as far away as the internet. And when that happens, then the service worker springs into life. It can go and fetch multiple things. It can synchronize things with the data keep, its caches, whatever. And then the service worker can go to the interface and open a tab or show something like a notification. Now, this stuff is really, really new, and most of it isn't in Canary yet. And despite that, and despite all common sense, we're going to do another live demo, and this one's going to work, right? Let's see. Come on, this one's going to be fine. This requires 2 phones, so the first one that had 1 phone failed, so 2 phones is going to be definitely fine.
What could go wrong?
Oh,
all right, so now I'm going to be over here, and then right. So I've got the app open, and I've got connectivity. Let's say I've got connectivity, and I've got the same number of points as Jake if I look in the leaderboard now. Oh, someone else is playing.
Oh, this is going to mess things up. So what we need to do, right, to make this demo work is I need to get more than 24 points.
OK, so
we're going to do that.
Help to get these answers.
OK, let's do this.
Yeah, OK.
OK, so, Alex here is on his home screen.
Well, yeah, and I'm going
to close the app as well. We're going to close
it.
Thanks, whoever was playing that. You've made things really easy for us. Right. OK.
Food. We can do food.
I can do this. OK.
We can do food.
False.
False?
I know the first question that comes up is false. I didn't even know what it was. OK. That's honey, water, and yeast.
Honey, water, yeast.
No.
Oh, no.
Yep.
Yes.
Excellent. Right, OK. Go.
Go.
OK. So I've got 24 points now. Let's go for potatoes. OK. Is that potatoes? Excellent.
Yeah.
OK.
32 points. All right.
Brilliant. Right now.
All right.
Come on, do this. You can really do this. So what we're requiring at the moment is connectivity. I know a lot of this was about making things work offline, but this is the one bit that requires network connectivity. Come on, you can do this. Please, we want one demo to work. Come on, come on, it's going to work.
Jake, why are you not online?
I am online, but we've got conference Wi-Fi, which is like being offline. Maybe if I keep pressing this button,
so are you suggesting that I shouldn't get conference Wi-Fi from my house?
There's a somewhat irony about a talk devoted to how making things work offline fine has failed due to a lack of connectivity.
Yeah, we'll go with ironical.
We can fight this. We're going to give it one more go.
One more go? Yeah?
I mean, the white screen is not great. I mean, that's not what we intended. What time were you up to last night making all of these work?
Let's not talk about that.
OK, that's fine. Here we go.
Also, let's not define work.
Oh, something happened there. Right, OK, so we're saying there's some kind of connection?
Not quite online.
Not quite online. Is that half online? How does this app work half online?
I'm not sure. I'm not sure what that is. You don't seem to be,
no, don't touch it. Oh, that could have worked. I'm going to press this button again. So we were worried about our talk underrunning. I think we've solved that problem. Come on, leaderboard. You can do it. I think we're going to have to bail. We're going to have to bail on the second demo. Maybe if we leave those there, And if it starts to work again, we can sort of pick up on that.
We'll leave
and
those
show
there.
all of the magic happening. Excellent.
This is what we get for switching Wi-Fi networks just a minute before the talk, right?
Exactly. Well, what would happen if I ditched off the Wi-Fi network? Do you think that would help?
I don't know.
Is the Wi-Fi here worse than not Wi-Fi? Oh, well, no one told us that. OK. Let's.
So no conference Wi-Fi for the house, then?
Let's go one more time.
All right.
That seems to be loading better. Does the leaderboard load? That's the big question. It does.
You seem to be winning, sir.
But what happens on your phone?
That's a really good question. Isn't it?
Why do you have no data? What network are you on?
Let's not talk about that either.
I'm a very scientific person, but I am using all of my psychic magic powers to make this work. Right, OK, I'm abandoning that. We'll come back to that when it works.
When it works.
When is the word I'm going to use.
When it works.
Thank you, Wi-Fi. I have a whole session in the sandbox tomorrow that depends on the Wi-Fi working. Come along to that.
Check Archibald, everyone.
As soon as you see that change, we'll cut
Yeah,
back.
yeah.
OK, so what you saw there was absolutely amazing, right? What we were hoping to demo to you there is push messaging. Like when I got a higher score than everyone else, it should have told Alex about it, even though he had the web page closed, he had the browser closed. And also what we're hoping to do is have background sync as well. So like we were saying before, playing the game without a connection, that's fine. But that means that when the phone tries to send the score to the server, it's going to fail to do that. But background sync means it can try and send that data later on. So say I'm playing the game without a connection and I improve my score. The score update request, that goes to the service worker because everything does. And then the service worker tries to forward that request to the quiz server. But without a connection, that doesn't go so well. Are you pulling a face there? Oh, my God.
Jake.
You have a notification. That's amazing. Oh, God. Oh, thank you. Thank you. And that's how you turn an atheist into someone religious. OK, but is there another part of that demo you would like to show me?
Well, I don't know. I found out about that finally working from my watch, which is pretty good.
So all using web technology, right? That watch doesn't even have a browser on it, but we're using web technology to send messages to it. That's incredible.
All right.
Right. Whew. I didn't realize this talk was going to be asynchronous. Right.
Well, I didn't realize it was going to nearly kill me.
Yeah. So originally, if we were offline, the score would fail to go up to the server, even though it was going via the service worker, just because of a failure in connectivity. But then the page can register for a background sync. Say, hey, I want some time later on to do some stuff. And then even if you close the page, even if you close the browser, when the phone regains connectivity, even if I close the page like that, the service worker will start up, and it will try again to make the request. And this time it succeeds because we've got connectivity.
Yeah, so setting up that background sync is actually really simple, despite what the demos might look like. So first, from our foreground page, we try to post the user's score. And if that doesn't work, we catch the failure. And so what we do is we wait for the service worker to be installed if it hasn't been already. From there, once we've got a service worker registered, we register for a one-off background synchronization. That'll happen sometime when the device thinks it has connectivity and power. You can also register for a synchronization that runs on an interval. The value you pass in is the minimum interval. This one is set to an hour, but that means that it won't happen any more frequently than once an hour. Heuristics are going to be used in order to determine what the right time for this to happen is, based on how often you use the application, whether or not there's power, how often the user uses the site, when they tend to use it, connection state, all kinds of crazy stuff that we don't really have a total, easy-to-understand formula for.
And if we know that two background syncs are sort of scheduled for like 10 minutes apart, they'll coalesce into one, so we can reduce a lot of the battery impact of these things.
Right. So of course, you don't get background synchronization for free. The user will have to grant you permission in order to be able to do that. And they'll be able to revoke it later. So it's a good thing we guarded our request behind that registration.
But if they do grant permission, over in your service worker, you will start to get a sync event. And you'll get an ID for those, so you know which synchronization you're dealing with, because you could have one on an interval, and you could have a one-off one. And once you get those, you can do whatever you want, really. Like in the installation process, you get this event.waitUntil thing, and you pass a promise into it, and that defines the length and success of the synchronization. If you give it back a rejected promise, it treats that as the synchronization failed, and it will be rescheduled. Even if it's a one-off one, like sending the score, if we signal that we failed to do that, it will reschedule it for some time later. In terms of sending the score, we're going to get the score from a database, which could be IDB or whatever, and we're just going to use fetch to post it up to the server. And if that fails, the promise rejects, and it will reschedule the synchronization. If we do get a response back, we're also going to look at the status code. If the status code isn't 200, we're going to throw an error. If you throw an error within a promise chain, that rejects the promise. It does the same thing, which will throw that rejection up the chain into waitUntil, and it will reschedule the synchronization. And that's it. Using the fetch API makes this stuff so much more simple than XML HTTP request, which is terrible. So now the score has successfully reached the server.
And at that point, the server knew that I had lost first place. So it told Google Cloud Messaging, which relayed it back to the service worker on my device, which decided to show me a notification. And I clicked that notification, which sent a message back to the
service worker. You helped write this spec. You need to remember it.
Which responded by opening up a page on my device. So how did we set up the push messaging?
Alex.
Good question, Alex. From that page, you want the registration ID that you've been sent from the server. Just have it be included with the page, or use an empty string if it doesn't have one already. From there, you can register for push notifications. If you've already got one, you'll get back the details of your previous registration right away. Otherwise, the browser will probably ask the user for permission. Assuming the permission is granted, you'll get back the registration details from the promise that you register with. And then the registration details give you an ID and a URL that you can send back to Google Cloud Messaging. But other vendors are going to use different systems for this.
Yes, it's not a lock into Google Cloud Messaging. Every other vendor will have its own messaging platform. They're welcome to use Google's, but I doubt Apple will, for instance. Now your server can send messages to GCM, which will then be sent to the user's devices. And this will wake up the service worker and fire a push event that you can see here. And you'll get a little bit of information with that, just a very small amount of information. If you've done push messages on native platforms before, it's a very small amount of information. But it'll be enough to tell us that we've lost a lead. If we needed more information at this point, we could go off to the internet and fetch that stuff. But in this case, we're just going to do a new notification. And this is a platform native notification, meaning it will show up on your watch or whatever, as we saw in the demo. So if the user taps that notification, you'll get another event inside the service worker, notification click. And in response to this, once again, you can do what you want, but we chose to navigate to the leaderboard so that you encourage the user to see who they're losing out to and by how much. All of this stuff is just using primitives. You don't have to do what we've shown today. Take it apart. Build something crazy with it. The service worker blows the doors open to heaps of new possibilities, more than we've just talked about today. I am genuinely really, really excited about it. Can I use it in production today?
Well, if you check out is Service Worker ready yet, you will find out the clear and unequivocal answer is no. But get ready. A lot of this stuff is in Canary already in some form, and we're racing with Firefox and other browser vendors to get implementations shipping as soon as possible. But no matter who wins that race, we expect that the web will win.
Yep.
And in fact, the network control portions, the fetch event, that sort of thing, are going to land in a couple of months in Chrome.
And that's Chrome stable.
Yeah. Background sync and push and those sorts of things are going to take a little bit longer, but there's going to be a steady drumbeat of those coming soon.
And you want to be ready to start using these things as soon as they land, because the service worker is best used as an enhancement to your site. Because the first time the user visits your site, no one's going to have a service worker, even if the browser supports them. So they're very much an enhancement. So as soon as it lands in browsers, it's useful to you. Give its features just to the browsers that support them. And if you use very simple feature detection, your site will work uninterrupted in browsers that don't support Service Worker.
Right. That's exactly what we did with the quiz app. That was built by the Polymer team, not us.
Yeah, it didn't require like a heaps of re-architecture. Like, I know when I was at Lanyard, if we wanted to do the app cache stuff, we had to start a new Mdot site.
No.
Because you had to re-architecture everything to use app cache. That is not true with Service Worker.
No, they handed me an app, and I made it work offline. It was that easy. But the second that this stuff lands in Chrome, millions of users are going to have it accessible to them across tons of devices. And so now is the time to start learning it and try to figure out how it can benefit you and your users and the sites perhaps that you already have deployed.
Yes, and if you're looking for some inspiration, the W3 Web Mobile group are currently compiling Service Worker patterns, and they're looking for contributors. So if you want to start writing demos, come up with use cases, or see examples that other people have made, this is an absolutely great place to do it.
At Google, we want the web to be first class. We want it to be an application platform that you can use with everything with a browser. The Service Worker opens up a ton of new possibilities, and we've only shown you a few of them today. But we're really most excited about what you're going to go out and do with it. We can't wait to see what you build next.
Thanks. I think we have a little bit of time for questions, if anyone has any.
Other than, how did your demos go so well?
How'd your demos go so well?
Practice.
So I noticed that there was no committed support for IE and Safari yet. Do you know the reasons for that? Are they working on a separate spec, or is?
So the question is, what's the deal with IE and Safari? I mean, Mozilla, we're quite heavily bought into it, but what about the other guys?
So obviously, it's very difficult for me to speak for my own team sometimes, let alone other vendors. So what I can tell you is that we've had positive signs out of Microsoft. They've come and talked to us at the public working group meetings about service workers specifically, and we're encouraged by that. But obviously, it's a question that you should probably ask them. The great news is that it is progressive. So if you're building a thing that works with service workers, because it has to work on that first page load, it's always going to work across browsers. So you should just not build your stuff to require service workers all the time. But if you have a local data model that's doing synchronization with the backend, you'll be in a good position to take advantage of it on all the browsers that do have it. Our hope is that by shipping quickly and having multi-browser support, it's going to create a drumbeat of amazing things that you build that will sort of get everyone excited. We sort of saw this work with Webgl, and I'm hoping for a similar cadence, if not faster.
Hey, Alex, I was thinking about the web components case specifically in HTML imports. When you use the fetch API, are we going to provide affordances so developers can granularly listen to the loads internal to that HTML import document?
Can I take that?
Please do.
Yeah, so the question is, currently it looks like in examples we've shown that you make a request and you get the full response back. But we're wanting to do something more granular than that. The stream spec is in process. I mean, we want to ship before them, so we've detached them as a requirement. On a request object, you've got .body. And at the moment, it's this kind of empty object with as JSON, as text, which just, but we're going to convert that into a stream when streams land. And it's still going to have those methods, but what they're just a shortcut to consuming the entire stream and converting it to whatever format. So you'll have a stream. With the example with the image, transcoding an image, we want you to be able to do that with video, like a fully live video with no defined endpoint. We want you to be able to take a new image, a new video format, transcode it within the service worker, and pipe it to the browser using streams, using transformation streams.
So the answer is, we don't have a way to do that right now. The good news is that if you know enough about your application structure, you can usually predict what you're going to need and put it in caches preemptively. And that's what the install step is really about, is making sure that if there are things that you know that are dependencies, you can capture them up front.
I have a question on what kind of the push technology we're using to push the asynchronous information back to the device.
So what push technology were we using?
Well, that's GCM, Google Cloud Messaging.
And that's going to be the standard?
Google Cloud Messaging, as part of the client side being standardized, the push server team here we've been talking with them about standardizing some of the Northbound API areas. That's an area that is ripe for standardization, but no one has committed to anything yet. If you talk to the other push servers, what happens is that the protocol on the wire between the phone and GCM is probably going to remain something that is going to be tied deeply into the operating systems of these devices in order to maintain battery life. But Northbound protocols between your application server and your push messaging server are the sort of thing where people are starting to have conversations. And the API that exists here on the phone is going to be absolutely standardized. And that's something that we've been pushing to get done very quickly.
Thank you.
Hi. So I know that you said earlier like some of the pitfalls with app cache, but that does work in the latest Internet Explorer and current versions of Firefox, et cetera. So is there any way besides user agent detection of kind of using app cache when it's available and then using service workers when that's available? Whereas like service workers, you can detect that in JavaScript, but you need to have the app cache header, which is... So
the question is, like, can you use app cache in the browsers that don't support Serviceworker and use Serviceworker in the others?
Is there any way besides using user agent detection to...
So if you have a Serviceworker registered, that effectively clobbers the app cache. So you can have both in use on the page at the same time. Well, you can have them both on the page, but the service worker will take over from app cache, and it'll become null. So yeah, you can have them both on the page, and app cache will work on the older browsers.
Okay, so it just won't use app cache, or will you have to explicitly block the app cache?
No, it just won't work. It just won't use it.
Okay, awesome. Thank you.
Cool.
I'm just wondering about updating service workers.
Yes. So there's a very long, very complicated dance which we didn't do, either in the slides or in the code. But the basic idea is that updating is the worst and nastiest bit of pretty much any product that has to be always up to date. Chrome goes to extreme lengths to make sure that you are always up to date on the native client side of things. With regular websites, you don't have that problem, right? You're always fetching from the server as long as you haven't far future expired something. So you're always up to date. So what we're doing with Service Worker is we're making sure that you do cache the Service Worker and all of its dependencies, but we check usually when you go to that site, and we request updates about the freshness of the service worker behind the back of the service worker itself. And we make sure that we do that at least once every 24 hours if you're using the app on a consistent basis.
And it will generally be once every request, unless you use HTTP caching headers to push it longer.
The general idea here is that you are going to have an update model that looks very much like Chrome's, where if you close all the tabs to a site, and the service worker has been downloaded and installed behind you, the next time you go to that site, you'll get the freshest version. And so there's a whole system in place in the service worker specification to make sure that that works that way.
But like everything, it's fully extensible, so you can do what you want. Like, if you're the next version in waiting, the user can still use the current version and while tabs are open. But this new one does have the opportunity to just go and kick the other one out. Yeah. Otherwise, it will wait for. But once you do that, you'll now be in control of pages that were loaded with the old version.
Did I mention this was very complicated? We can talk later. It's very complicated in the sense that updating any live code is very complicated, and we're trying to make this easy and give you a simple model for it, but we can describe it at length later.
Thank you. Yeah. Right, and I think, we've got one more from the Neiman. Make it quick.
So for people trying out service workers, do you have a good place where you're collecting all the feedback and ideas and suggestions?
It's a good question. So the specification and a lot of the ideas that have been poured into it so far, sorry, the question was how are we going to be collecting feedback about service workers? So a lot of the discussion has moved to the public web apps mailing list at the W3C because they're sort of the organizing body that has decided to take on the standardization effort. And that goes well, but a lot of the action is happening on a GitHub repository. If you search for service workers, I think it might be the first or second hit.
So that first URL there is to the status page that says which parts are supported by which browsers. There is a link to the spec from there as well.
Yeah, and so file issues there, we do look at them, we are triaging them, or send an email to public web apps and we will give it a look.
Excellent. I think we're definitely out of time. So thank you very much, everyone.
Thank you.
Cheers.